Good afternoon. I'm Renu Joseph, a program manager of Earth and Environmental Systems Modeling in the Earth and Environmental Systems Sciences Division that Gary Giernot manages. Thank you for giving me the opportunity to talk about the joint NOAA DOE Precipitation Processes and Predictability Workshop. This workshop came about because program managers from DOE and NOAA wanted to address the challenge of precipitation predictability, and we decided to bring together our communities to address this. So the workshop co-chairs included two program managers from DOE, me and Sally McFarlane of the ARM facility, and three program managers from NOAA and the US CLIVAR program director. So why is DOE interested in precipitation predictability? Precipitation predictability is relevant to the 5 goals of the EESSD strategic plan. It is also relevant to almost all the programs and facilities within our division. Because precipitation is not captured well in Earth system models, from DOE we've had a few workshops that address this. The first workshop focused on the integrated water cycle. The second workshop that's highlighted here focused on a particular aspect of precipitation, and this was on atmospheric rivers. The third workshop, which was conducted the year before in 2019, focused on developing benchmarks to evaluate Earth system models. Just like DOE had its emphasis on improving precipitation in models, NOAA has had a focus on precipitation prediction. Particularly, the Climate Program Office within NOAA has a focus on precipitation processes and predictability as indicated by the NOAA Precipitation Predictability Grand Challenge. This figure on the right is a figure that was taken from our very first workshop report, but has constantly evolved to include nuances as we've progressed. And so this is to indicate DOE's interest in precipitation from subseasonal to multi-decadal and centennial. Since there have been many workshops focusing on precipitation, what is particularly new about this workshop? This workshop takes a comprehensive look at precipitation, ranging from process understanding to predictability, to prediction skill, model biases, observations, and so on. It also looked at precipitation from different points of view, from the point of view of end-to-end integration, from model development through process studies to prediction. In addition, this particular workshop came at a time when many innovative capabilities had been developed with respect to Earth system models. Right now, we do have global storm resolving models, models with regionally refined meshes, and also machine learning is beginning to be extensively used in this in modeling. And so bringing in these technologies along with the process understanding was an important aspect. Additionally, the timescales ranged from weather to multi-decadal. Since this was a virtual workshop, we had about 400 participants, and they all had access to the Slack channel, and so we could see active and lively discussion going on. The program organizing committee that I've described before also brought together a scientific steering committee, which consisted of NOAA and DOE funded scientists, as well as folks from international institutes like the ECMWF. If you notice the list of the scientific steering committee, you see Anna Barrows, who's part of BERAC, who was also there as part of the committee. Now, while discussing the scope of the topics that we could discuss at the workshop, we decided to narrow it down to something tangible so that we could focus on the continental US, and then into the future, we will be extending it into looking more at the global scale. So spatial scale was just limited to the contiguous US, and temporal scales ranged from subseasonal to multi-decadal. The Program Organizing Committee and the Scientific Steering Committee together came up with 4 major themes for the workshop, around which the workshop sessions were organized. And I will be going into these 4 themes in more detail. Each theme was also then organized with particular science questions that each of the themes had to address. And so they focused on sources of predictability, model biases, observations, and data, and what are the new targeted observations and process studies needed, as well as how do we collaborate both nationally and internationally. The first theme focused on limits and sources of predictability. The figure on the left captures the essence of what was discussed during the session. For instance, you have different modes of climate variability associated with different time scales. MJO with intraseasonal, ENSO with interannual, and so on. In addition to these modes of climate variability, you do have prediction skill associated with soil moisture and anthropogenic forcing. None of these have been captured fully so far. For instance, if you look at the figure on the top right, it indicates that MJO skill has increased over time. However, if you look at precipitation prediction skill, the bottom right figure, it has remained almost flat, emphasizing the need for better representing and understanding microphysical processes. Several strategies were proposed to enhance understanding of precipitation predictability. There needs to be more research in the fields of surface-atmosphere interaction, modes of variability, understanding how diabatic heating can be used as a source of predictability. All these areas need more emphasis with respect to research. In general, connecting large-scale circulation to regional precipitation and exploiting forecasts of opportunity should be looked at. For that, there are several tools and ideas that were discussed. Seamless modeling, machine learning were all discussed as part of this theme also. And this also ends up showing up as an important area in many of the other themes. And so let me quickly go to those themes too. The second theme focused on precipitation biases, and since the scope of the workshop was over the continental US, it was precipitation biases over the US. The primary process discussed was related to the mesoscale convective systems. This is because more than 50% of rainfall over the US or in summertime originates from mesoscale convective systems. And many of the Earth system models, if you look at the multi-model mean, you do find a deficit of precipitation related to mesoscale convective systems. The top right figure and the bottom right figure indicate that in the multi-model mean as well as in E3SM. Another bias that was talked about was about the diurnal cycle of precipitation not being captured. Strategies for addressing precipitation biases is based on the knowledge that biases at different scales need different ways of addressing them. So if you're looking at cumulus convection, boundary layer processes, or microphysical processes, or the interactions and feedbacks amongst them, we need to make sure that they are for the appropriate scales that we're talking about. One way in which it was proposed that we address these precipitation biases was by using a hierarchy of models ranging all the way from from LES models to single column models, then regionally refined models to global Earth system models. Using this whole hierarchy along with observations at the appropriate scales, we will be able to figure out and address biases in a continuous way. Theme 3 focused on interdisciplinary processes. In the case of this workshop, when we talked about interdisciplinary, we meant interactions across interfaces. So, for instance, land atmosphere, ocean atmosphere, sea ice atmosphere, uh, interactions that affected precipitation were discussed. So also we did talk about stratosphere, troposphere interactions, and also interactions across scales. For instance, the figure on the top right is from Anna Barroso's talk, where she talks about energy across scales, going from the larger to the smaller, and how it is important to capture this energy across scales. The figure at the bottom talks about how stomatal conductance is important for transpiration and how that affects precipitation. And while talking about strategies for understanding interaction related to precipitation, we discussed unified modeling systems that span across scales that capture the detailed processes that we discussed. So getting, for instance, troposphere, stratosphere interactions and all in the model that you look that spans from weather to climate scales is important. There was a discussion about bringing in observations and data, and also making sure that models can be evaluated with respect to them. Improving the vertical resolution of models also was emphasized. These are just snippets of what was discussed at the workshop. Theme 4 focused on regional precipitation. In this particular session, we focused on phenomena that affected different precipitation in different regions. Tropical cyclones, extratropical cyclones, mesoscale convective systems, etc. were talked about, and how it was important to capture regional precipitation. For instance, light drizzle is a problem in most models. And with regards to strategies for advancing regional precipitation, folks from NCEP emphasized how their regional rapid refresh forecast system can be used for this purpose. In addition, there was talk about how high resolution models and regional models will help. The importance of unified forecasting system again was discussed in more detail here, and also enhanced observations and bringing in modeling and observational communities together was emphasized. Development of standard benchmarks to evaluate precipitation was discussed. This slide captures the essence of what was discussed at the workshop. Today I presented the workshop outcomes in terms of the 4 sessions and the 4 themes that were there. But there were also these 5 questions that if you're more interested in them, I'd refer you to the workshop report. And essentially, the topics at the workshop can be distilled into these 3 main topics: sources of predictability influencing precipitation, the physical processes and their representation, and biases and how you would address them. The modeling and observational strategies that were highlighted as part of this workshop are ones that span a whole range of scales in terms of a unified modeling system, going from climate scales to weather scales. The importance of global storm resolving models was emphasized during the workshop. The use of a hierarchy of models so that you can evaluate biases and correct them, and also the observational components were emphasized, and the ways in which the observational output can be used to evaluate models, and more emphasis needed to make that happen was discussed. When we run such a big workshop, there's always a question as to what are the outcomes of this workshop. Success for workshops come at different scales. At the interagency front, NOAA and DOE have worked together, and as part of the US Global Change Research Program and the Working Group on Water Cycle, we do see precipitation predictability going forward and being informed by this workshop. NOAA is seeking in both national and international partnership for the global precipitation experiment, which is informed by this workshop. Into the future, we do see the potential of climate process teams. These are teams where modelers and observationalists come together and work together to advance a particular goal. And we do see potential activities like that into the future. Within DOE, this FOA, this workshop report is being referenced by 2 funding opportunity announcements. We see it informing the AI for ESP activities. We also see this encouraging more coordination across the DOE and NOAA modeling and metrics and benchmarking groups that NOAA and DOE have. Instrumentation and data products are informed by this workshop, and tracer and sail are highly relevant to the goals of this workshop. On an individual basis, attendees indicated that they enjoyed being part of the workshop and indicated that it will enhance collaborations. So I'd like to thank all of you for your attention and remind folks that this workshop report is available on the website. Happy to take questions. Thank you.